Dear learners, welcome to NIOS. Today, we are going to learn about properties of fluids. In our last class, we had already seen that what are surface tension as well as what would be the surface energy, and today we are going to deal with its application. So, the main learning objective of this slide is that what would be the understanding of applications of surface tension. Now, the very first example is that how a mosquito do sit on the surface of water. Now, through this diagram, we try to analyze. Now, if you can see that in the right hand side portion, the surface of the liquid is given by the horizontal slant and the leg of the mosquito has been shown. When a mosquito do try to insert his leg on the surface of the water, then the resultant tension that has been created by the legs of the mosquito are given by T, as you can see on the left hand side of the diagram. Now, since T needs to be resolved by using the components of vector, and it would be resolved as in the component of T sin theta and T cos theta in the vertical direction, because the resultant is having an angle with respect to T cos theta. As well as on the other side, the same thing happens. Now, since T sin theta are the two components which are equal and opposite to each other, therefore, they will get cancelled with each other, and the resultant force that is applied by the legs of the mosquito, which is given by mg, are counterbalanced by the T cos theta, and both the components are equal in opposite direction to that of mg. Therefore, in this manner, the mosquito do sits on the surface of the water. So, here the surface tension do imply a great role. Now, through this diagram, we can see the very first diagram do shows that what would be the excess pressure on the concave side of spherical surface. So, very first surface is nothing but given by the plane surface. As you can see, the tension on the above of the surface are equal and opposite to each other. On the convex surface, the tension is at the lower side of the resultant, and in the concave surface, it is in the upward side. The resultant force is in upward side. Now, what is actually a spherical drop? As you can see from the diagram, if we try to look from the vertical height, the spherical drop seems as to be having a structure of a circle. The actual radius of this spherical drop is given by small r, and when an excess pressure is placed over to this spherical drop, a certain displacement is given by this dotted line at the outside of the surface. This dotted surface displacement that has been increased is denoted by delta r. So, we can see that what would be the excess pressure that has been implied by this liquid drop. So, you can see the difference between the initial pressure and the final pressure is given by the excess pressure. So, how to calculate this excess pressure? So, first of all, we need to see that what would be the change in a small change in the area. So, a small change in the area will be given by the difference between the final surface area with that of the initial surface area, and the resultant comes out to be 8 pi r delta r, as you can see at the last of the result. So, when this value is given by the work done amount, which is the extra surface energy, and whose value is given by the product of the surface tension into the change of area. So, that will be given by the product of T into 8 pi r delta r, right. So, that what would be the work done? So, the work done is given by nothing but the surface extra energy, which is equal to the work done to expand under the pressure difference of excess pressure, which is nothing but given by the product of pressure into the volume, the change in volume. So, what will be the change in volume? That is given by pressure, the last equation that is denoted by equation number 2, and the product of 4 pi r twice of delta r. Now, combining both the equations, because both the equations are talking about the work done, so we will get the excess pressure is given by twice of the surface tension upon the original radius of the spherical liquid. Now, the same case arises in case of soap bubble. So, the difference between the excess pressure inside a soap bubble to that of the liquid drop is nothing but twice. Therefore, if we were getting an excess pressure for the liquid drop has to be 2T upon R, here we will be getting 4 times of tension upon the radius of soap bubble. So, conclusively we can say that yes, the soap bubble is having twice the excess pressure of a spherical drop having the same radius or an air bubble in water. So, yes, an extra little pressure is there on the soap bubble. Now, what would be the role of surface tension in detergents? Because detergent is used in our daily life for cleaning the object. So, soap and detergent, they do lower the surface tension of water. And due to this, there is a cleaning process which takes place, because since the high surface tension of pure water does not allow it to penetrate easily between the fiber of the material. But when we add a detergent, it lowers the surface tension, which makes it easy to penetrate through the fiber of the material or the dirt particle or whichever we take, like oil or molecular interaction between two different materials. So, due to this, we can say yes, the detergent do allow to lower the surface tension. Now, you can see from the diagram, the cloth is given by the green surface and the grease is implied over to the cloth. So, when we imply a detergent, it lowers the surface. So, detergent molecule with head attracted to water forms a strong intermolecular force with the molecules of grease or dirt or oil. So, we can see that so many of detergent molecules have formed, and once it is formed, it allows you to that the intermolecular forces increases, so it lifts the cloth into the water. The cloth will be lifted up, but the greasy material will remain in the water in which we are washing. So, in this manner, the grease has been removed from the cloth. So, a detergent is dissolved in water. It weakens the hold of dirt particles by making so many attractive detergent molecular over that thing. So, the addition of detergent whose molecules attract water as well as oil drastically reduces the surface tension of water or oil, and this is the enhanced property of the surface tension. So, this kind of process is using the surface active detergent is important, not for only cleaning the clothes, but also in recovering oil, mineral ores, etc. And this is nothing but the application, the practical application that we use in our daily life for using the detergents and how to remove the dirt particles over there. And this let us know that yes, there is an application of surface tension in daily life. After this, we will be learning that what all other things are there that could be used up for the liquid by using the surface tension, its energy, and what all other methods are there. So, till then, thank you.